Law and Order Statistical Victims Unit, Episode 5, Validity and Reliability. In the original research system, blah blah blah, yada yada yada, aka DSP. These are their stories. Okay, reliability and validity. We want our research to be both reliable and valid. Reliability is the extent to which the results of a study can be replicated. In other words, repeated. You want to be able to get the same results within a margin of error that's reasonable time and time again. So it's like using a little mold to create little figures. You want to be able to get the same figure each time when you use the mold again and again and again. Validity is the extent to which the study measures what it is supposed to measure. So you want to be on target. You want to be measuring what it is you're setting out to measure. If you're measuring something other than what you want to measure and you measure it really well, you'll still be reliable, but it won't be valid. Okay, so here's some pictures. Here's a picture of kind of a conceptual picture of being reliable but not valid. You're not aiming at the right target. You're aiming at another target. Okay, it's reliable because the points or the arrow shots are close together, but it's not valid because you're not measuring what you want to measure. You're not hitting your target. Here's the low validity and reliability. It's kind of all over the place, so that's not very reliable. It's missing the target a lot, but it's randomly scattered out about it. So that would be low validity. Not reliable, not valid is when it's scattershots everywhere and it's not even centered around what you're trying to do. Here's what we want. We want both reliable and valid. We want to be aiming and hitting the target, and we don't want our error to be very large because we want to get roughly the same results every time. Okay, so there's different aspects to validity. The first one is called the construct validity, and that is the extent to which a measure used correctly operationalizes or represents the concepts being studied. So constructs are the ideas, the things that are being measured, the concepts being studied. And you want your measure to correctly operationalize, represent that construct or that concept. If you're looking at the weight of Cocker Spaniel puppies, that's easy. You put them on a scale, you report the ounces, maybe pounds and ounces. Your measure correctly operationalizes the construct there, the weight. What if you wanted to do the health of a Cocker Spaniel puppy? Would measuring the weight be enough to represent that completely? Would measuring body temperature be enough to represent that completely? There are some constructs that are just difficult to measure, and you have to have some sort of research basis to be able to state that what you're measuring is a reasonable tool for representing the construct you're wanting to represent. So some of the ones that are really hard, some of the constructs that people are interested in but are difficult to represent well are attraction between two people, creativity, anger, intelligence is even hard. We do IQ tests, but that measures a very specific kind of intelligence, not the whole construct of intelligence necessarily. Memory is a difficult construct to measure. Depression is a difficult concept to measure. So construct validity, that's how well what you're using to measure something actually represents it. And the word for that representation is operationalizes. Internal validity. This is the extent to which the findings match the reality of the research problem. Okay, even if we operationalize something really well, if we weigh a bunch of Cocker Spaniel puppies, but our scale is messed up, and we end up with all kinds of incorrect data, there's no internal validity there. When appropriate, the extent to which the observed results are caused by the independent variables. When you're trying to show that relationship of cause and effect, that causal relationship can be measured as as a means of internal validity. It's the extent to which the observed results are caused by the independent variables. So if we're noticing that there's a relationship between global warming and film crews, did the global warming bring the film crews to actually document it, or did the travel of the film crews actually cause the global warming? So if you do a study and you indicate one or the other, how much is that actually true? How much of that is a valid statement? So here's this little cartoon of penguins actually wondering, do you think all these film crews brought on global warming, or did global warming bring on these film crews? Good question. There was actually a study when ice cream first came out that they found that as people ate more ice cream, there were more deaths by drowning. So they worried that maybe ice cream was not safe. Okay, well, that turned out to not be internally valid to come up with that conclusion, because upon further study they found out that when temperatures got hotter, got higher, people got hotter and they swam more, and they also ate more ice cream. So it just happened to be that it was the fact that it was summer, or the fact that the temperature went up, so people ate more ice cream and they swam more, so there were more deaths by drowning. It wasn't a direct cause of eating ice cream that people ended up drowning. So there's an example of low internal validity. External validity. This is the extent to which the findings can be generalized to a larger population and to similar research problems. So what you want to do is it's the extent to which you can go outside of just exactly what you studied. Okay, what implications does it have? How much can you generalize? So what you need to do is make sure that your sample is representative of the population by using a random sampling method to ensure external validity, if you can. Okay, so what we have to be careful with is there's the source population, the population we hope to use. And then there's going to actually be the study population, the population from whom you can actually get members to be part of your sample. And so your sample, what we hope to be able to do is to at least be able to generalize back to our study population. What we'd like to be able to do is generalize back to our source population, but because our ability to do random sampling from a huge population is limited, we may not be able to do that. So there's some challenges for our external validity. Okay, guys, just wanted you to keep these things in mind. It's more of an explanation of why we do what we do, and also really that construct validity. You really need to think about that when you are coming up with your survey questions, and when, if that's what you're doing, or when you're designing your experiment, or whenever you're creating your instrument for data collection, you really need to keep these ideas in mind. Okay, guys, that's it. That's all I have for you for today. So you really need to be thinking about how you're going to collect your data. That's where you're at. You're ready to make some sort of instrument. You're ready to come up with a design for your sampling. You're ready to actually have an instrument for collecting the data and having a complete plan. And even on how you're going to analyze your data, you really need to think about that, because that will help you with your construct validity if you think about how you're going to analyze it. Okay, guys, if you have any questions, I'm always an email away. Talk to you soon.